Welcome back, everyone, to another AI Talks with Chris and Nita. Ready for a deep dive today.
Always. What are we exploring today?
So we're going to be looking at instance-based learning, which is a really fascinating corner of machine learning.
Oh, instance-based learning. I like that one. It's pretty intuitive, like it kind of mimics how we learn sometimes.
Right, exactly. Like, think about it. Sometimes we learn by remembering specific examples, and it turns out computers can kind of do that too.
Yeah.
Our source for today is a document simply titled instance-based-learning.pdf.
Straightforward.
It's nice and simple.
So
if you jump in.
let's do it.
All right, so instance-based learning. Can you break that down for us a little? What exactly are we talking about here?
Sure. So instance-based learning is this really interesting approach in machine learning where you don't actually build like a big complex model up front. You kind of wait until you need it, you see a new example or you get a new piece of data, and then you try to figure out what to do with it based on what you've seen before.
So it's like holding off on studying until the test is right in front of you.
Exactly. It's sometimes called lazy learning because of that.
Lazy learning. I like it.
Yeah, it gets right to the point.
So, okay, lazy learning, it waits till the last minute. But how does that actually work in the real world? Give us a concrete example.
Okay, well, how about something we all deal with? Email spam.
Oh, yeah, the bane of my existence.
Right. So like a traditional spam filter might just block emails that are already on some kind of blacklist.
Right.
But with instance-based learning, the filter is actually comparing a new email to a whole bunch of emails that it already knows are spam.
Okay.
And it's looking for similarities, patterns. Like, is the sender the same?
Go ahead.
Are there similar keywords, phrases, that kind of thing? So it's all about recognizing patterns.
So it's like recognizing a familiar face in a crowd. Even if the person's wearing a different outfit, you can still tell it's them.
Exactly, and this is where things get kind of cool. The system needs a way to actually measure the resemblance between those instances. Like, how similar are these two emails, really? That measurement is what helps the system decide, okay, should I flag this new email as spam or not?
Okay, that makes sense. But isn't that a little inefficient? I mean, storing all those examples, making all those comparisons.
Yeah, you've hit on a key point there.
Okay.
It's definitely one of the trade-offs we see with instance-based learning. So on the one hand, a big advantage is that it's incredibly adaptable. Since it's not tied to some rigid model it's built beforehand, it can actually handle new data, new trends much more easily.
So it's constantly learning. It's like updating its knowledge all the time.
Yeah, you could think of it that way. The source actually brings up a great example. Online shopping recommendations. User preferences change all the time.
Oh, yeah, for sure.
But an instance-based approach can adapt to those new preferences as they come up, making sure that the recommendations stay relevant and you don't need to like completely redesign your system every few months.
Okay, that makes a lot of sense.
Yeah.
So it's adaptable. But you said there's a trade-off, right? What's the downside?
Well, all that flexibility does come at a cost.
Hmm.
The source document specifically calls out that instance-based learning can be computationally really expensive, especially when you're working with these massive data sets.
Right.
So you have to store all those examples and then you have to compare them all the time. That takes a lot of memory, a lot of processing power. So while it's amazing for situations where you need to adapt, it's not always the most practical option.
So it's a bit like choosing the right tool for the job, right? Some situations call for a flexible approach. Others might need something more streamlined.
Exactly.
Yeah.
Now, something else I wanted to mention is that the source also talks about several specific algorithms that use this instance-based approach. Some of these you might have actually heard of before, like k-nearest neighbors.
Ooh, k-nearest neighbors.
Yeah.
That one does sound familiar. It's like finding your closest friends on a map, right?
Yeah, that's actually a really good way to think about it. So picture each data point as like a little pin on a map. When you get a new data point, the algorithm looks at its k nearest neighbors, which are the data points that are closest to it on the map. Then it basically classifies the new point based on what the majority of its neighbors are.
Got it.
But there's also a little nuance here. The choice of k, like how many neighbors you look at, actually matters a lot.
Oh, interesting.
If you pick a k that's too small, you might overemphasize individual outliers, you know, those weird data points that are off on their own. But if you pick a k that's too large, then you might oversmooth the boundaries between different categories.
So there's like a sweet spot.
Exactly. It's a balance.
That's fascinating. So even within this one approach, there are all these layers of complexity and decision-making. It really highlights the challenge of designing these systems, doesn't it?
It really does. And, you know, thinking about all this, it kind of makes you wonder, if our brains sometimes learn this way, by remembering specific examples, what does that actually tell us about how we teach and learn best as humans?
Wow, that's a great point. Something to think about for sure. Well, thanks for taking us on this deep dive into instance-based learning. It's been really enlightening.
My pleasure. Always fun to explore these topics.
And to everyone listening, thanks for joining us. We'll see you next time on AI Talks with Chris and Nita.